A motion application begins with sizing and selecting the correct motor and drive combination. Motioneering can help simplify this process. The first step is to create a login, which will then provide you access to Motioneering. If you have previously registered but forgot your password, you can request a link to reset your password. The link will be sent to the email address that was used in the original login. Once you have registered and logged into Motioneering, you will enter the My Projects page. Here you will create the projects for your application or review previous projects that have been created. Once created, the project can be reviewed, copied, shared, or deleted. At this point, we add a new project. First, we create a project and give it a name. Your project name can be anything, such as the machine name, and the project can contain multiple axes within it. We can then set our units for the project and use those relative to the application. While the default is metric, each of the units can be changed to imperial units, or they can be mixed and matched. If needed, a unit can be changed later within the project. You can enter the project by clicking on Project Name. In this screen, you will find the different axes that are part of this project. Since we have a new project, we start by adding a new sizing. First, we give the new mechanism a name. In this example, we will simply call it Axis 1. The different axes are located under Select a Mechanism Type. In our example, Axis 1 will be a lead screw. Click on Create Sizing. Throughout Motioneering, we find an icon which is a circle with a lowercase I in it. These are information spots which will help explain that parameter. When you click on the icon, a box will drop down with the explanation. A second click on the icon will hide the information. Also, different warnings are available to remind you if an essential parameter has been omitted, such as screw lead, or if the elevation might suggest a brake on the motor. The first area you see is the mechanism specification area. Here, we will input mechanical information about the mechanism type. Each mechanism type will have a different section. While this video will show the screw mechanism, others, like the conveyor, will ask you to supply information on the conveyor, rollers, and force. The process for inputting information for each of these mechanisms will be the same, even if the specification request is different. Returning to the screw axis, there are 4 sections that describe the screw: the screw definition, force, part and tooling, and slide. The screw definition defines the screw's lead, inertia, and efficiency. If the screw inertia is not known, Motioneering can calculate it by selecting either mass or density. These choices will require other information such as diameter, length, mass, or material density to determine the screw's inertia. Force defines the continuous force of the application, which is a force that is present even during dwell. Part and tooling defines the mass of the material being transported or the tool which is being transported. The slide is the mechanism on which the part and tooling will ride. It is the part of the mechanism that is connected to the screw and the bearing supports. This is also where we account for gravity by selecting the elevation. As the information is entered, you will find some helpful tools. For example, as you click through the different parts of the mechanism, the animation highlights the part you are defining. Parameters, represented by a Greek symbol, can be clicked to show the most commonly used industry standards. The down arrows on the left show unit conversion numbers that can be selected, while the units down arrow on the right lets you switch units. Note that changing the units does not change the number entered. After the data has been entered for the mechanism, it must be saved by either clicking on Save or by hitting Enter. Most screws will have a coupling which will connect the motor shaft to the screw. The coupling's inertia can be defined in one of three different methods. These are direct inertia entry, defined by mass and dimensions, and defined by density and dimensions. The reducer can be defined in two different methods, as a gearbox or as a set of pulleys. Because it is possible to have multiple reducers in an application, a block diagram of the couplings and reducers will appear to the right of the screen. One of the most important steps is to define the motion profile. Some applications require a simple profile with a quick index and dwell, while others may have a more complex profile. You may create a motion profile segment by segment, or you can use one of the pre-programmed options like the triangle move or a 1/3 trapezoid move. You'll have 4 input parameters to create the motion profile. You'll need to choose 2 parameters in order to generate the move. Continue adding moves until you've completed the motion profile. If multiple axes require the same profile, you can create the profile once, then export it to a file which can be imported by another axis in this project or another project. Modifications can be made within the profile for additional loading or addition of mass. This can be used to account for variable forces which change throughout the profile. It can also be used to represent the mass that changes throughout the profile, such as a hopper being filled as it moves along. When the mechanical parameters and motion profile have been entered, the process of motor selection can begin. In most applications, there will be an understanding of the motor type required for the application. Note, if you have gotten this far and have no idea what type motor you might require, contact your distributor or customer support representative. The product choices can be filtered by selecting the voltage, whether a holding brake is required, customizations such as shaft seal or washdown or food grade are required, or if a specific feedback type is required. Selecting more than one choice can make it difficult to narrow down your search. We can also set up the inertia ratio threshold. Setting this will flag in yellow those systems that exceed this ratio. Now we can refresh the calculation. In the table, there will be systems highlighted in green, yellow, and red. Green meets all torque and velocity parameters. Yellow meets all the torque and velocity parameters, but is greater than the inertia ratio warning threshold that we set. Red means it does not meet either torque or velocity required. A system can be selected and the details can be viewed. The results can be printed or made a PDF. We can save this system, which will put a star next to it in the search results. It will also add the motor and drive model numbers to the mechanism as the selected system. The sizing results details will show the available, required, and percent of margin. If the system had exactly enough torque and speed, the margins would be 0%. If the system has twice the torque and speed, the margin will be 100%. In the middle of the page are the inertias for all the components in the system. It will also display the total reflected inertia of the system. The profile points display the required torque by segment and which, if any, are in regen. At the bottom of the page, you can request a quote, pull up a 3D model for the motor, or 3D model of the amplifier. Because there is so much more that Motioneering can do, it is highly recommended that you attend an instructor-led class or participate in self-paced course modules. As always, feel free to contact your distributor or your customer support representative for assistance.